All right, so for most of the rest of this series of videos, we're going to focus on polynomial functions. So polynomial function is basically made up of a bunch of power functions, right? So in very, very general form, we have a sub n x to the n plus a sub n minus 1 to the x to the n minus 1. There we go. I gotta say it the right way, right? So each one of these, this a sub n, there we go, is our coefficient on each of the power functions that make up our polynomial, and the n, or the n minus 1, and so all of these are our powers, right? Power. But that first one's important because it's going to give us what's called the degree of the polynomial. So a sub n minus 1, a sub n minus 2, so on and so forth. We're just using those because if it's a big enough polynomial, you could run out of a, b, c, d, and so on. So those coefficients are real numbers. That's the only requirement on them. We don't want any imaginary numbers on our polynomials. That makes the math really complicated. And our exponents for polynomials are restricted to being whole numbers. So remember, the whole numbers means non-negative, so that the power is greater than or equal to 0. So, and it's integers. Okay, so no fractional powers, no negative powers, just plain old regular numbers. Okay, so here's some examples of polynomial functions, various polynomial functions, and we want to identify the function, what the type of function, the degree, the leading term, and the leading coefficient. And so we're going to go back just a minute and make sure that we're clear on, so our leading coefficient is the coefficient on whatever the highest power term is, and our leading term is the whole thing, the leading coefficient with x to the power. So that's going to be our leading term. So we'll just write that. And it's not necessarily the first one in your polynomial. So usually in standard form, we'll have our highest power first, but that's not going to always be the case for the things that you see. Okay. So what do we have here? We have f of x equals 7 minus 4x. So we're going to look at this and we're going to say, here's our highest power of x. It's the first power, first degree, and we recognize that is linear. And so our leading term is that whole term that I circled, the negative 4x, and the leading coefficient is just the constant off of that negative 4. So then we look at the next one and we say, okay, what's my highest power? It's the third power. So there's our degree. This one is a cubic. All right. Our leading term is going to be that whole term, the 4x to the third, and our leading coefficient is just the constant off of that. Now, h of x here is equal to negative 8, and we know that that's a constant function, right? That would be just a graph looking like that, right? A horizontal line. And so we're going to name that a constant function. The degree on this one, there's really an x to the 0 there. So this is degree 0. And our leading term and this time our leading coefficient are exactly the same. Okay, next one up, we have this j of x equals 1/2 x to the 4th minus 3/4 x to the 3rd plus 2x squared minus 3x plus 1. And we're looking for our highest power. Our highest power is 4, so our degree is 4. Our leading term, the whole thing connected to that x to the 4th, 1/2 x to the 4th. And our leading coefficient, 1/2. And this one is going to be called a quartic. Q-U-A-R-T-I-C. All right. And then one more for good measure, right? This time, the highest power is definitely not the first power. It's the first term in the polynomial is the second one. So our highest power is 2. Our leading term, 3x squared. Our leading coefficient, simply 3. And of course, this one is a quadratic. Okay. So we'll break here or pause here before going on to the next part.